Mikey wears a hat. Welcome, everybody, to the American Space Museum. I'm MarQ Marquette, and we're so glad you're with us for this episode with Mr. Terry White in the house. Hey, Terry.
Hey, how we doing today?
Well, great. It's a rainy day. They're going to try to launch a SpaceX, or maybe not. There's a satellite on the pad just 9 miles away from where we broadcast Stay Curious and have been doing so for 2.5 years. We're into our 690th episode or so.
Great.
Thanks to my co-producer, Marty Winkle over there. Hey, Marty, how you doing?
Doing good, Mark. How are you?
Good to hear you on our UCAC microphone here at the Stay Curious Studios. We're doing good. We got a great show with Terry lined up here, and talk a little bit about the garages of the space shuttle. And we just want to remind you all, stay curious here. Our video podcast is always Monday through Friday. You can see it on YouTube and Facebook, Spotify, and Twitch. We've had over, this year, about 30 guests at least. Over half of them are space workers, a few astronauts. And we're pleased that Terry wants to join us frequently. Tell them what your job was, Terry.
I started out as a mechanic and worked my way through the program for 34 years, up to an orbiter processing chief.
And the shuttle garage is called the Orbiter Processing Facility, or OPF in the acronym world of NASA. And Terry, our wonderful shuttle era, 30 years, we were talking in a little pre-production meeting there that an orbiter like Challenger may have gone to space 3 times in 1 year, and
Correct.
maybe for a 10 or 15-day mission. So it's in space for 30, maybe 40 days at the most. And then the other 322 days, where is it?
Well, it starts out, if it lands here at the runway, it's only 1 day, getting it less than a day, getting it from the runway back to the orbiter processing facility. But then it goes inside, as Mark likes to call it, the orbiter garage. It goes in there. And then we have it for several months, taking it apart from its last flight, removing whatever payload came back, even if it's just the fixtures that held the payload and all the wiring, and then installing a new payload. And then we had to take and disassemble the aft section to take out the 3 engines, send them to the engine shop. We had a lot of work to do in the crew module, and of course, a lot of work to do on the external surfaces of the orbiter, which most people know as the tiles.
We'll see some pictures about that whole process. Yes, the orbital processing facilities are the home base, really, for the orbiters. That's where they live, around their workers, and we'll talk a little bit about that here as we go through with Stay Curious today. Terry, you've got an Endeavor hat on there. There's the nose end of Orbital Vehicle 105 is its tail number.
Correct.
On there. And took me a while, thank you for the correct, took me a while to memorize all the orbiter tail numbers, but that's sort of what you called them by, was with the numbers, wasn't it?
Yeah,
the paperwork.
We referred to them by their tail number and not so much by their name, but the rest of the world wanted to call them by name.
Right.
So,
well, Columbia was OV-102, and Challenger was OV-099. And we'll have a whole show about that one time, about all the
because there's a long
5 or 6
explanation
orbiters.
as to why it was called
Yeah.
099.
Yep. And then Endeavor, when it was built as a replacement for Challenger, it's got some Frankenstein parts from some of them in there, doesn't it?
But, well, and it had parts. I mean, they'd already started building some spares, some parts for 105, and they'd even built some parts for a 106 to have some spares.
Well, you know, can you believe 50 launches on the Space Coast this year already?
Yes.
Artemis was the 50th.
Yeah.
And nobody's ever seen that around here. And their 51st looks like this out there. Our good friend Carlton Bailey. Hey, Carlton. He's out there to photograph a satellite that's to be launched a little before 4 o'clock today is a schedule. And then at like about 9:50 is a Crew Dragon supposed to go to the space station.
Okay.
And but this is what the weather looks like today.
It's a little foggy to be launching, especially under the space shuttle days.
Well, unfortunately, that Falcon Heavy was pretty foggy, and nobody saw it in the Titusville and Space Coast. It was so foggy. I saw it at Cocoa Beach area.
Yeah, people in Cocoa got to see it, but yeah.
Marty, we got a question or comment?
Yeah, we have a question from Cliff Watson.
Cliff, hey, Cliff Watson in Pomona, Australia.
When you saw Artemis take off, did you feel the pressure waves from the thrust?
You know, it's a good question, Cliff. Thank you, buddy, for answering that and supporting our. He's a great amateur astronomer down there in Pomona,
Okay.
Australia. Depended where you were to answer that question, Terry, because there was didn't feel anything at all 9 miles away west of the pad across the Indian River here in Titusville. But I talked to several people that were on the campus at various sites. Cape Canaveral or Kennedy Space Center, and they felt it.
Yeah. Well, see, I live just southwest of the Space Center, and everybody was telling me it was going to be more powerful than Apollo, and I did not get the same feeling that when Apollo lifted off. I mean, Apollo was a lot stronger than Artemis was, but a lot of vibration, windows rattling, doors rattling, and that, but not near the noise that I expected.
And it was really an atmospheric thing that people are telling me, because I've heard louder Falcon 9 launches.
Yes.
But for example, Mike Leinbach, who launched the last 37 shuttles, as launch director, he was blown away, he said, by it. He was on top of the launch control center, right beside the VAB there, right over my shoulder, on top of there. And boy, he said, oh man, it was in their chests and they could feel it and all that stuff. But
He's a lot closer than you and I were.
yeah, it's 3 miles away there. But good question, Cliff. Thank you, sir. But of course, that launch of Artemis rocket there, it looped around the moon on Monday morning. There's a picture of the moon. They have a camera on one of the solar panels looking at Orion and the Earth and the moon there in the background. So everything seems to be nominal, which is the word we want to hear, normal.
It means everything's working right.
That's right. You can catch up with it on a blog, the Artemis blog. We posted that on our Facebook page, so you can follow it on there. So I'm not exactly sure what there is to follow, but as it's looping around in an area around the moon where we're going to put the Gateway lunar outpost that will be the space station between the Uber that is going to taxi that's going to be the Orion vehicle and the moonlander, Elon Musk's Starship. So, well, let's get back to what our wheelhouse here with Mr. White, Orbital Processing Chief. There's a beautiful picture. We're going to talk about some of that process where the scaffold's put in there to work on things. But first, let me go down here. What happened there, Marty? There we go. We wanted to show you a 1976-77 era before the shuttle was launched even. The orbital processing facilities were built. Marty, would you point those out before you run that errand? The OPFs 1 and 2, show them right there, Terry.
Yep, there they are. The 2 is on the left and 1 is on the right. And as you can see in the background just above them is the runway and the towway, where we would bring an orbiter in after flight, bring it in there and bring it to the hangars and stop in front of the hangars to change out the spacecraft operators, because we actually had 2 technicians on board operating the controls and that, because the orbiters were still powered up the systems to maintain them, and then change out the spacecraft operators. Then we'd tow it into the hangar, and our next step was to get it up to its maintenance height so all the platforms could be lowered and we could go to work on it.
All right, we'll see some pictures of that here in a minute. OPF 3 is not built yet. It's kind of right behind the VAB. And those of you that just were wondering how big this 500-foot tall structure really is, the stars and stripes blue of that flag is the size of a basketball court.
Yep, and each stripe is the width of a highway lane.
All right, yes. And that's the bicentennial logo in 1976, celebrating 200 years. Yeah, Marty.
Yeah, the stars are 6 foot across from point to point.
Yeah,
our stars are 6 foot across from point to point. It's quite a sight. It's our Devil's Tower, so to speak. I love just going over any causeway and looking over my shoulder, and just there it is. And so we love it. Well, these are specialized buildings for the tail and the rudder to fit in. They had to cut out a hole there. You can still see those. What's in these buildings now, Terry?
Well, OPF 1 and 2 is operated by the Space Command, and that's for their X-37.
Mm-hmm. The space plane that just spent 900 days in space orbiting the Earth. I'm told the Chinese have one up there too, like that. I didn't hear about that.
I don't know. The Chinese don't keep me informed of their business.
They don't. Well, we're going to talk a little bit about the processing here. Go through the steps here. As you see, the orbiter's main engines are purged, and of all of their liquids and stuff that could be in there. The payload bays are open, and any hazardous payloads are removed. The fuel tanks were drained of cryogenic reactants, and high-pressure gases were vented from the environmental control and life support systems. So there's a lot to this living, breathing machine, Terry, and all that stuff seems to, particularly, you got some pressure maybe to get your payloads out of there.
Well, yeah.
So tell us the first days of the shuttle.
Initially, we get it in, and like I mentioned, we had to get it up to its maintenance height, so all of the facility interfaces could actually mate to it and that. But then, just so we could increase the man loading of the building, we had to get the hazardous commodities off of the vehicle and get it safe for more workforce to come in and work. And at the same time, we started installing strongbacks. The payload bay doors are not strong enough to support themselves in gravity, so we actually put huge steel beams mounted to the doors, and we used a 4-crane system to open up the payload bay doors, and then we could start on removing components of the payload, because all of our payload customers, if it was a payload we brought back, they wanted their payload. But and that was the big part for the mid-body payload wise, was getting all of the stuff from the previous payload out, all the electrical interfaces, everything associated with that. And then that was called download. Then we could start uploading for the new payload, installing all of the interfaces and that, even if it was a payload that would not be installed till it went out to the pad. Some payloads were vertical payloads designed to go in and out at the launch pad, but we put all of the electrical and fluid components in the OPF, and then we tested them, so all they had to do was do the final installation at the pad.
And we have, we welcome your questions to Terry here. I have a couple pieces of paper I didn't grab over here. I'll have Marty hand to me there if he can. But I know some of a lot of people are anxious to see Terry today, and we're glad Margot Watson is one of them watching there, and appreciate Margot. She has got a guest that might be on Stay Curious here soon. We've got a question, Marty.
Yeah, we got a question from Amanda Chambers. She says Jackson, 9 years old, is asking how big is a space shuttle, and how long does it take to build a shuttle?
It actually, hi Jackson, it took several years to actually build the orbiter itself. And that was built in California. So your aunt's Uncle Larry worked out there building the shuttles, the orbiters in California, as well as myself. I'd be loaned out there. But like I say, it took several years on that. And then once we got it down here, it still took us a while. For Columbia, the first time, it took us almost 2 years at Kennedy Space Center to finish building it, work out all the problems associated with it, and get it ready for its first launch.
It is 122 feet long. Why don't you show your little shuttle model there?
122 feet long.
It is, the wings are 78 feet from tip to tip. And its wheelbase is... his wheelbase could be 78 feet, same as the wingtips. No. It's probably about 58 feet.
Well, no, it could be if they're talking the wheelbase from nose to main.
Yes. From the wheelbase, that's right. It's the same as the wing. The tail is 58 feet high, and the cabin, you wonder where these guys are sitting, they're 23 feet above the ground. Yep. So it's 2 stories, a 2-story building above the ground.
Now, an interesting point about the size of the orbiter, the length of the orbiter is the same length as the Wright brothers' first flight in North Carolina.
The distance it flew.
The distance it flew. So if you would go to talk to them and tell them after the first flight that, hey, we're going to build a spacecraft the size of your entire flight, and we're going to launch it into space over and over again, they'd look at you and say, and people call us crazy.
That's right. That's exactly. And as we look into the, we throw up a picture here that is, looks distorted, but it's a 360 degree of the office area there. And like I was saying, we know Margot Watson was anxious to see you today, Jillian Marie, Tom Errico, Larry Reed, Andrew Oliva, and Corey Skinner. Corey Skinner are all watching Stay Curious today. Or said they would be today watching you today. What are we looking at there?
Okay, we're looking at the entrance in the center. That's the doors that we go in and out of to get in the orbiter processing facility. And the one that's directly behind me is the operations desk. So everybody coming in to work checks in with the operations desk to make sure of any hazardous tasks that are going on that day and to ensure that they can go work their tasks.
Marty, you had a question or comment?
Yeah, a comment by Carlton Bailey. Mission scrub today.
Mission scrub today. All right, Carlton. I'll bet he's glad he drove out there for nothing. Again. Yep, doggone it. And Carlton said there was something that might push everything back to the weekend that wasn't weather related. I forget what that was. Something, some priority.
Maybe it's
the
Thanksgiving
airspace.
Day.
Yeah, that is. It's the
Maybe it's
Thanksgiving
Day.
I think it was the airspace for Thanksgiving. With all the flights, it's hard to clear for the launches in there. So, well, once we get the shuttle inside the orbiter, inside the OPF, the heat shields are removed from the engines, and scaffolding is installed around the orbiters here. You see that view there, striking view of the scaffolding so they can reach things. The main engines are locked in place and eventually removed, some of them, right, Terry?
Yeah, we eventually removed all three of them.
And any repairs that you need to do are done right there, all right? Look at the tiles under. Here's a 360 degree, again, kind of a weird looking picture, but you get the idea of these tiles. Are very light after they return from space. And I learned from Mike Leinbach, looking at Atlantis at the visitors complex, that the darker tiles are usually the ones replaced. Is that right?
They were. If you look in that picture there, you can see some of them look a lot blacker than the others. The gray ones have been on since the maiden flight of that orbiter, and the black ones or the darker ones are ones that we replaced over the life of the orbiter.
Oh, so your people come up to you at the end of the day, Terry, and say, we've got a list here of tiles that need to be replaced. How quickly could you get that tile made? Because they're all customized.
Yeah, in the early days, they were made in California. We didn't have the facility here, so it took the time to make them out there and then ship them down here. Later on, they opened a facility here at Kennedy Space Center right across the street from the OPFs, and we had the ability to make them here. So if I had a tile and the computer had the information for it, it was basically 2 days. If I had to use a pattern maker to actually make a foam replica of what we wanted the tile to be, that would take a couple of days, and then we'd send it over and they would duplicate it and send us a tile in 2 days to fit. But it took a little over 2 weeks to remove and replace an individual tile.
Wow. And there were how many tiles?
Well, on Atlantis, a little over 24,000. On Columbia, for its maiden flight, it had over 32,000 tiles.
Wow. And somebody is sitting there with a clipboard keeping track of every...
Yes, a lot of documentation, but we did a minimum of 5 documented inspections on the orbiter's thermal protection system from landing to launch. We were constantly inspecting it while we were working on it. You'd be working on one tile or one area and looking around there for any potential damages, and then we'd have to write them up and go work what the engineer or what the supervision determined we needed to do.
Beautiful. We're talking with Terry White, shuttle manager, and involved with the shuttle, its entire 30-some-year history, a 30-year flight history, of course, and you had about 10 years in development beforehand. An important part of America's space age, and that's why we love devoting time on Stay Curious with just the people like Terry that built the shuttle, kept it going, and the result is 22 years continuous occupancy in space.
Correct.
In our space station. Marty, we got some good questions for Terry White.
Yeah, I have a question from Gary Giral. Terry, did the vehicle stay powered up while in the pod? If so, were the APUs powered up or did they have external power supply?
Okay.
Great question,
Yeah.
Gary Gerald, who is a peanut farmer in Georgia.
Okay. The APUs provided us power on the runway, but as soon as it was safe to get around, then we hooked up the picture earlier where you saw the big vehicle behind it. It had hoses and cables and everything going to it. Then that supplied the air conditioning for the people that were still inside the vehicle, and it also supplied all the power for the orbiter systems and that. And that's why it was, again, important to get it inside. All that was still running till we could get it up to the maintenance height and then hook up the external sources to the T0 umbilical on the aft sidewalls of the orbiter.
The T0 umbilical, Jerry, not the T -0.
Yeah. Well, they call it the T0 because when that separated for flight was when the count got to 0. So that's the same way, the same places they hooked up out at the pad, and then they had special tail service masts out there. And when all of that disconnected, it went inside these huge masts on the MLP, and big steel doors slammed closed so that the systems didn't get burned up.
That's why I ask these questions, because these acronyms have really deep meanings. That it's just not a thing to throw out there. I'm not making light of it or anything like that. It's great. Thank you, Gary, for reaching out to us. And he's one of our great Stay Curious listeners. He and his wife have been in the museum. And he said Marty and I definitely helped him get through the pandemic 2 years ago when we were doing this show. Old school, weren't we, Marty? Next question, sir.
Okay, from Amanda Chambers again. Mason, 6 years old, would like to know how far the space shuttle can go.
How far can it go?
6-year-old.
Yeah. Well, it could travel at 17,500 miles an hour, but how far can it go? It depends on which mission. The earlier missions, they only flew a couple of million miles. Later on, they flew a lot, but it was all orbiting around the Earth. So he's got the quotes here from some of the different millions of miles, but most of them, the farthest it would go out was to service Hubble Space Telescope. It was designed for low Earth orbit, close to Earth.
Young Mason, he's absolutely right. But every mission they went millions of miles.
Correct.
Usually,
around the Earth.
Around the Earth.
But,
and the one that traveled the most, Discovery, Orbital Vehicle 103, it went almost 150 million miles in its 39 flights.
Yes, but the average distance away from the Earth was usually in the 145-mile range above the Earth, because
Right, but you go 350 miles to get up to Hubble.
Yeah, Hubble, that's the farthest it went, was Hubble. 350 miles out.
Yeah. Marty, another question?
Yeah, you got it.
Okay, great.
Thanks, Mason.
One thing that, this is dangerous stuff, folks. We can't emphasize not just some of the payloads there in the payload bay, but the orbital maneuvering system, the reaction control system has these what are called hypergolic fuels, which is liquids when they hit each other, they ignite. There's no spark needed on there.
And now,
so everything, every day going into there, the next day you could kind of breathe easier. I'm kind of saying,
as we got more hazards offloaded, we got pyros offloaded. But the hypergols were one of the big concerns. And when we were working on hypergol systems, we had to clear the entire building to everyone except the technicians and the quality that were in a suit. We call it an escape suit, but it's similar, looked almost like a suit an astronaut would wear. Mm-hmm. But they'd be wearing that to go in and work on these systems, because a couple of breaths and you were no longer living on Earth. So,
Right.
yeah,
No, oh,
but
dangerous stuff.
and then if we had to do heavy maintenance on either the orbiter maneuvering systems, those two humps at the base of the vertical, or the forward reactionary control system, they were designed to come off of the vehicle, and we took them down to the Hypergol maintenance facility, which was out in the boondocks, and they were way away from everyone else.
Mm-hmm. Terry, we're looking at the processing of the payload bay. You can't even tell there's an orbiter in there, the way things are configured there. But we have Space Lab in there. Talk a little bit about you have three distinct sections to the orbiter, and certain people you only get in the engine area called the aft, the cabin, of course, is the other end, and the payload in the middle.
Yeah, so we broke it down in basically three areas. One was the forward, and that encompasses everything to the bulkhead that starts the beginning of the payload bay. So all the area that the crew's in, the nose landing gear, and that are all encompassed in that. Then the next section was the mid-body, and that encompasses from the front of the payload bay to the back of the payload bay, which is basically 60 feet, but it includes the payload bay doors, the mid-sidewalls, and the wings. And then the last portion is the aft, and that's from the aft bulkhead, and includes the vertical, orbital maneuvering system, the engines, the body flap, and that. So that's how we broke it down into work areas. And the man loading was different in each one. Of course, the size of them and that, but the forward and the mid-body, you had to be in clean room attire. Myself, I had to wear a full mask on because I have facial hair and that. Women, no makeup, no jewelry, no watches were the only jewelry you could wear. But and then in the aft compartment, you could work in street clothes.
You just in these three distinct areas there in the OPF, if I clocked in to work on the aft section, I'm not going to be able to wander around and get anywhere else.
Well, if you don't have a task, we have an orbiter integrity clerk that's going to say you just can't go in the mid-body because you want to.
Right.
What's your task? Again, because of the man load. So, yeah.
Yeah, and woman load too.
Yeah.
When you say man load, you mean occupancy.
Correct.
In there, but that's your terminology that you're using there.
The term in those days and those systems was the man load.
So you got all the dangerous stuff off, and now everybody's just processing and getting it ready for the next flight. How many worker bees are in there on a regular day?
Actually, there's not a lot of hands-on technicians. There's a lot of support people, but a couple of hundred techs spread over 3 different bays.
Right.
Yes.
So, and then you have a couple hundred people looking over their shoulder.
You have people looking over their
that in
shoulder.
a
You
good
have
way.
people writing the paper for the work to do. You have people tracking the paper and tracking everything we do.
Okay. Marty, question?
Yeah, from MarQ, how long did it take to change out the main engine?
Well, generally it took a couple of weeks to get everything deconfigured, all the plumbing and electrical disconnected inside and that. But then when we had all 3 engines ready to come out, we had a special heister that had a fixture that went right inside the engine nozzle. But we would pull 3 engines in less than 24 hours. They would go to the engine shop, and then we would do the rest of the work inside the aft. They were refurbishing engines. Later in the flow, when we were ready to put the engines back in, we would install 3 engines in a 24-hour period. It took a lot longer to hook everything up after that, but basically, it was because you took away all the work area from anything else going on in the aft when you were installing engines.
There's the aft end with the body flap off there.
Yes. Yep.
Yes, Marty.
And that's just physically to change the engine out, but we had several days of testing it.
Oh, yes. Yep.
Once it's installed.
Yep. Once it's installed, we had a lot of time testing it. They tested again in the VAB and tested again at the pad.
And these SSME, Space Shuttle Main Engines, called the RS-25s now, tell us how they're being used.
Well, they were such a reliable engine. They're using them on Artemis and other spacecraft and that. But interestingly enough, we could remove engines in the VAB. If we had another orbiter and when we removed those engines, we detected a problem and they wanted to inspect the ones that were already left the OPF, we could remove engines in the vertical position, and we worked and removed engines at the launch pad.
Wow.
I know one flow, we removed the engines 5 different times during that single flow.
What was that orbiter? Remember?
I don't recall.
Let me go back this way to show you. Of course, one of the great partners of the shuttle era was Canada. They built the remote manipulator system, the arm there. That's obviously been taken off. And you got a photographer down there in the bottom. Right there's a photographer taking a picture of stuff there, which I said to Terry, I said, you got to get used to people taking your picture all the time.
Well, we did. Photographers had to take photographs of a lot of different components as we were installing them. We called a lot of that closeout photo. As we were covering something up, they had to take a picture of what was there when we're attaching something above it. In this case, in the arm. And as you see that big yellow beam that's attached to the arm,
right.
That arm is designed to operate in zero gravity. It cannot support itself here on Earth, so it has to have that big fixture attached to it strictly to support it.
Which means, Terry, during the development of that arm, they have to incorporate in the design a latch type of system or whatever to pick it up. That's something that is always interesting to me, the contact points on the shuttle and so forth for just the brute strength things to lift things up.
Just
have to be
not only like the arm, but lifting the orbiter itself. It had 4 attach points to lift it when we lift it in the VAB or lift it to put it on the 747. Then we have attach points all and special fixtures for the forward reactionary control system, for the orbiter maneuvering systems. We have special fixtures built to pull out payloads when they come back or to install payloads. So a lot of them are unique to a certain piece of equipment.
Oh, right. This piece of equipment could never be used on anything else but the orbiter arm there. So neat picture there, just in many ways. Not just were still photography taken and movies, but you told me that there's quite an array of cameras in the facility.
To my knowledge, there was over 700 cameras on Kennedy Space Center, but cameras were focused on different places. Like in the mid-body when we're installing a payload, only so many people could be in there doing it, and we had other people that we called looky-loos, but they could have been a payload customer, they could have been just a member of management that wanted to watch that payload going in. We were not going to let them go in the vehicle to do that, so they could look at it on a TV, bring up the channel and where that camera is. We could watch things going on out at the launch pad. I could actually look right over a technician's shoulder when they were working through one of the cameras, and then I'd tell them later and that. But, you know, you could check the surf report, you could check traffic conditions on the Space Center. So the cameras were filming all kinds of things.
Could you get into them remotely from home if you had to?
No. Okay. This was all the internal camera system.
Marty's got another question, and he's going to ask it on our Tom and Vicky USIAC microphone that they bought for us.
It's not Tom and Vicky, it's Tom and Mark.
Vicky's name was on the check, not Mark's, okay? No, we don't want to get the woman mad. I know what I'm talking about, Marty, okay?
Okay, anyway, Dave Stang is asking, Terry, I've seen pictures that various Apollo crews had left notes on the walls of their spacecraft. Can you comment on any notes that were left on the walls of the space shuttle?
Like Kilroy was here, he's talking about.
There were not notes left on the vehicle itself, with the exception of the Endeavour crew for STS-134, which was supposed to be the last flight. And I personally did not see it, but I understand that they had signed inside one of the lockers in the crew module for the last flight, and then NASA agreed to fly STS-135 Atlantis, so Endeavour was not the last flight. So, but for people to sign, we had what's called a white room to go inside the crew module or the mid-body. You had to suit up in special attire in that, and you did that in what's called the white room. So it was clothing that went over your clothing to make you completely clean, and that clean as a hospital. But we allowed people to sign the walls in the white room.
Interesting. So we're ready for the next mission. All right, we're gonna, before we tow it out to the VAB, you've installed mission flight kits. What are the mission flight kits?
Okay, these are the different kits, like the toolkit that the astronauts are going to use in flight. They're different things that they have to hook up once they get to space. Okay, so we have a thing called crew equipment interface test when we have the orbiter almost ready to roll out of the OPF. The That crew comes down here and they go through all the different functions that they're going to have to do in space, understanding the cabling, understanding their tools. They take their tools out and that, and they do things like the mission specialists that will be operating the robotic arm. They actually get a hold to handle the controls that actually the joystick that controls the arm. And one of the comments we used to get is the controls are too stiff, and we had to remind them that they've been practicing in a simulator in Houston, and everybody and their brother has been handling that control. That control is sloppy. The one that they're handling here in the orbiter is exactly the way it's supposed to be and the way it'll be in flight. So,
all right. Well, we're enjoying Terry White here. He's got his Endeavor hat on. We've had a lot of pictures of Orbiter 105 in our parade of photographs today. And you get it ready to tow out. We wanted you to point out, you brought a piece of material here, show and tell. You see the nose of the shuttle, and it's got kind of a big nose on it there.
it does.
What's all that about, Terry? What's
Okay.
it made out of? And
The nose and the leading edge of the wing, the gray materials, they see the most heat on reentry. They see up to 3,000 degrees. So they are made out of reinforced carbon. Now the tile material that's on the majority of the orbiter is extremely lightweight. The reinforced carbon is extremely heavy.
yes,
And this is the actual thickness of the leading edge of the wing. The nose cap is much thicker than this. So, and the nose cap and the leading edge of the wing have additional insulation behind the reinforced carbon. The tile system has no backup behind it. It's the tile, and then it's the aluminum or composite structure underneath.
Well, thank you for sharing that with us there, Terry. So, folks, you get the orbiters ready. There's a few things that they have to put in the out at the pad, like live animals and things like that. So, what do you think, folks, would be the last thing that you would do, the last step before rollover to the vehicle assembly building for this shuttle? What do you think would be the last thing to do? Well, you got to weigh the orbiter.
Yeah.
And why? So I can't think of an analogy like you don't go on a vacation to weigh yourself before you go to see how fat you're going to come back. Okay, from your vacation.
Before you go
you might.
lifting this extremely heavy vehicle, you have to calculate its center of gravity. You're going to lift it in the VAB with two cranes. You're going to lift it horizontally with two cranes. Then you're going to lower the back crane and disconnect it, and you're going to take it all the way 500 feet in the air on a single crane. But in your lifting operations, you want to know the center of gravity. Even though we had a weight log where we weighed everything we took out and put in the orbiter that weighed more than a pound, it is still, we wanted to weigh it. So we had a very large set of bathroom scales.
Oh, no way.
Yes.
You didn't have a big, nice Toledo scale hauled in there?
That we would bring the orbiter down on its landing gear. We would put it up on top of the scales, weigh it. And it's interesting enough, we had a gentleman from the early days, and he would come in there, and I don't know exactly what he tracked, but he would come into the move director, the guy responsible for getting the orbiter ready to go to the VAB and getting it weighed and that. And he would walk around, look at a few things and that, and he'd write a number down on a piece of paper, hand it to the move director, and say, "Don't look at it until you weigh it." And that guy was always within a couple 100 pounds of the actual weight of the orbiter.
What is the actual weight of the orbiter?
Well, it varied, especially with the payload.
yeah, with
in
the
there.
payload. Empty.
Yeah. Well,
100 tons, right?
Well, yeah. Anywhere flight weight was normally 179,000 up to a little over 200,000 pounds.
All right. That's well, I find that interesting that you weigh it out last there. So so we're getting it over there, and we'll have Terry back and talk more about inside the OPF. But once we get outside the OPF, a few little kind of tourist photographs here Terry is going to share with us here, where you walk outside work after clocking in, and oh my gosh, there's two orbiters
Yeah.
on the property
Yeah,
there.
there were a lot of times there was a single vehicle outside, but there were several times during the program when we had two vehicles outside. The one on the right, you can see the yellow strongbacks to support the payload bay doors, but it's been taken out and it's probably going over to the VAB to store for a while we get another orbiter into the hangar. In the early days, we had 4 orbiters and 2 hangars, so there was always somebody wanting to get inside the hangar. Later on, they built OPF 3, so we had 3 places, but there were still times when we had to move an orbiter out of a hangar because another orbiter was landing and we had to safe it. And the only place to safe it was in an OPF. So we had to get the hangar empty to get the next orbiter
So
in
where
there.
would you put the third orbiter?
Well, we would store it in the high bays of the VAB. Not the one that the mobile launch platform was in, but the ones on the west side. There was 2 additional towers over there. We would put it in there and provide power to it over there while it was in there.
On these days, the workers become tourists and
That's right.
and
Yeah.
looky-loos themselves, right? It's
Yep.
always and this didn't happen very frequently, did it? Where you
No,
had-
but every time we rolled one out, whoever was working wanted to go outside and watch it roll over. But yes,
Beautiful aerial shot there of 2 orbiters facing off there. Marty, we've got another question.
Yeah, State Stang is asking, was the launch of the Hubble telescope the heaviest launch weight?
no,
No,
uh,
Gamma Ray Observatory was.
that was the
93.
heaviest. I was
Or
thinking.
Chandra may
I was
have
thinking
been.
one of the components for the space station. One of the last things they took up the space station was the heaviest.
Could be. But no, Dave, several missions were heavier than Hubble, including, I know, the Chandra X-ray telescope. There could be some of those trusses were pretty heavy on there. But good question, nonetheless.
It could
on
be the
there.
cupola module because that was pretty heavy.
On there. And we got a lot of nice people watching us today there. You want to give a shout out to some of them out there?
Yeah, my nephew Mark Hurlbert is on there. Cliff Watson,
And
Rebecca Vicknair, my daughter.
all right, Rebecca. Hope Dad has represented the family well. Ophelia.
Ophelia,
She's
yeah.
in Normandy, France.
Okay. Dave Strange or
Stangy.
Stangy.
Yep.
Okay. Steve Hammer, Doug Forrest.
Yep.
William Whiting, Mark Usiak.
yeah.
Lori White Taylor, my sister, and Amanda Chambers that's already come through with a couple of questions. My niece, Katie Izell.
We've doubled our audience
Yeah.
today with your family watching. Thank you.
They like me. Madeline Vanderland, Gary Gerald, Daryl Jong.
Daniel DeYoung.
Oh, Daniel.
Airplane
Okay.
pilot.
Yeah. Cynthia Rossi.
Hey, Cynthia.
Yeah. Danielle, and that one is
Lazzarini.
okay. And Peggy Hurlbert, my sister. So I got a lot of family on this
And
list.
Jeff Moore's watching. Thank you
Yeah.
all for staying curious today. Those family members out there, it's people like Terry White that we call national treasures here at our museum in a very serious way, Terry, because you did a job that never would ever translate into any other segment of society here, working society. These workers couldn't transition into the Detroit motor system up there or the oil companies or something like that. It's so unique, the skill set. Of course, many of them did and found fine jobs after the end of the shuttle era there.
Well, that's odd because at the end of the shuttle program, and I worked at a nonprofit we created to help people find jobs. But, some of the potential employers that say, well, we don't want, because your people are all specialists. I said, no, they're not. I said, they have a variety of certifications, but I got a guy that is installing a $500 million payload today, and tomorrow he's repacking the wheel bearings for the main landing gear, just basically like you're packing wheel bearings on your car or truck. I said, so not all of our tasks are unique, but, our workers were unique.
And as we look at this unique shot of 2 shuttles facing off there, Terry, we got to remind people that you did work in a wildlife refuge.
Yes.
For 30 years there.
Yeah, so we would have rattlesnakes and we would have alligators and that. We had to sweep the runway for alligators and potentially any wild hogs before landing. But in the parking lot, sometimes somebody come back in and say, hey, you got to do something. There's an alligator under my car. I can't get in it.
Those wild hogs are something else, though.
Aren't
I
they?
think.
Yep.
Marty, we got anything else to share with our friends today on Stay Curious? We are going to take a short week this week. We're going to be closing the museum, of course, for Thanksgiving and Friday and Saturday. Give our team a good rest and so forth so that we can enjoy our families. And I appreciate our executive director, Karan Conklin, wanting to make sure we do spend a lot of good time with our families over the holidays. So we've been quite busy. Marty, anything else to share with there?
Just Jeff Moore, Terry. He says he worked with you.
Who?
Jeff Moore.
Okay.
Worked with you in the late 80s to the early 90s. He was a TPS QC.
Okay. So,
Jeff Moore.
yeah. So glad to hear from you, Jeff.
Yep. Thank you for staying curious. There you are out there, Atlantis in the background there. Not sure, was that towards the end there?
It looks like it because I think that shirt has STS-1 to STS-135, and I wouldn't have wore a 135 patch
I do see the
until the end.
135 patch on there. Kind of a wet, rainy day like we have here on the Space Coast. They scrubbed the SpaceX launch at 4 o'clock, and there's a Crew Dragon scheduled to go to the International Space Station about 10 minutes before 10 today. But I think the weather's going to be bad for that too. So. But it looks like it's going to clear off for our holiday time here. Terry, anything else you wanted to share with our listeners out there in Stay Curious World?
No, but one thing you see in this picture here, in the earlier days, we rolled over to the Vehicle Assembly Building, the VAB, on our actual flight tires. Well, we did puncture one of the tires, and luckily we had a spare tire already processed, but the Orbiter didn't carry spares. But so after that, they wanted us to start using the big yellow fixture there with 72 wheels on it. Right. And that was built for Vandenberg, even though we never processed vehicles at Vandenberg. But yeah, that is the Orbiter transport system. And we actually set the Orbiter down on there, raise the landing gear, and it would go over on that instead of exposing his flight tires. The next time the tires would be exposed to the outside air would be right before landing.
Yep. When they hit that about 3 seconds before landing there,
yep.
hit the gears there. Well, Terry, thank you so much for participating in Stay Curious and all that you bring to it. We certainly hope you have a nice Thanksgiving with your family there. Gobble,
yes.
Gobble. And everybody out there. Tomorrow, we're going to end our Stay Curious week with Mr. Hugh Harris, the voice of NASA. And we love having Hugh on the program, just like we do you. You know Hugh
Tell
quite
Hugh
well.
I said hi.
I will. He's been working up a little program about Thanksgivings in space. And so you want to stay tuned for that on Stay Curious tomorrow, Wednesday. So until then, on behalf of Marty Winkle and our good friend here, Terry White, thank you so much, Terry. Really appreciate it.
And on one show, I'll tell you about ice cream in space.
We will have some ice cream in space. We're going to have many shows with Terry. His second appearance this month of November, and we will have him back in December to talk about the whole process of this wonderful spacecraft, the Space Transportation System of America. So, well, until tomorrow with Mr. Hugh Harris, the voice of NASA, I'm Mark Marquette saying we can't wait to see you again to bridge the space between us.